Hi, welcome to my channel, JaberTime, where I do math videos from algebra to calculus and differential equations, simplified with examples. If you're new here, consider subscribing, and if you did like this video, smash that like button. If you have any questions or comments, leave them down below, and I'll get back to you. I do upload a video or two every week, and I'm so excited about converting all my math notes into simplified YouTube videos. Teaching over 25 years. Once again, thank you for being here and hope to see you again and again. Alright, let's get into it. Welcome to another topic for Calculus 1. It's Introduction to the Derivative of a Function. This is where derivative starts and differentiation. You could see in the graph, I have enough information about the introduction. If you look at this point right here and this point right here, this line right here, the major line in green, is a secant. Crosses the curve in red at two distinct points. To find the slope of it, we usually find delta y divided by delta x, and that's a slope. But in our case, since we're dealing with calculus and more understanding of the slope for the secant and the tangent, we're using or starting with t instead of x, time, s instead of y, position. So the slope for this secant line in green with the arrow on it is m for the slope of the secant line, which is y2 minus y1. y2 is s of t, that's right here. y1 is s of a, that's right here, over x2 minus x1, that's x2, that's x1. What's interesting, and that's one of the main parts about calculus and understanding where calculus came from. If you notice, usually in life we are not interested about the average between 3 p.m. and 5 p.m. We want the speed or the velocity at a single point, like at 3:15 p.m., at 7:12 p.m. And that's more important for us than finding the average velocity between 3 p.m. and 5 p.m., for example. So we're going to move from a secant line and its slope, which is called the average velocity. Why we call it the average velocity? Because of the units, as you could see, for x and y. Because distance over time will give me velocity. Now, imagine if I graph this one right here closer from this side, and I keep this point focused on A is our main point. T is a variable, but we want it to be less and less and less, so I could give or get close to A. So the second move, if I move one step, I will see this secant line. If I move another step, I will see this secant line. Eventually, by hand, by graphs, I cannot do it all, but eventually if I keep doing that as a limit concept, this secant line becomes the blue line, which is a tangent. Secant becomes a tangent. And the only difference between the blue and the green formulas, this is the average velocity. It's the same thing right here, up there, except we're applying the limit as t approaches a. As t approaches a. That becomes the tangent. Slope of the secant, slope of the tangent. That's my introduction. So we're going to be talking about slopes and tangents most of the time. Sometimes we just go back and revisit the average velocity. Next. So overall, if you have a parabola that is upside down this way, opening downward, we have a few things to consider or look at. This point A as a value for x, its output is f of a, so this is supposed to be marked up here, a and f of a. Left side is f of a. This tangent at this location touching this point at a f of a has a positive slope. From now on, you need to keep in mind what's a positive slope, what's a negative slope, and what's a zero slope. When it changes, when you move on the curve, your slope changes. The value of the slope changes, which is the ratio of rise over run. It gets smaller, 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 and then it gets from this line to zero because there is no change in y. Change in y is zero. Going down, this is called a negative slope. So keep that in mind. I have the graph here, and I have more about the derivative and the instantaneous slope. So we are concerned about the blue line. That's the main part. And we call the derivative of f of x at x equals a f prime of a. We now use this tick mark on top of the letter f, and we call it f prime. It's to refer to the word derivative. All right, what does that mean? It means a lot for us. Here is one by one. This f prime of a represents the instantaneous rate of change in the function f at a. Also, it means the slope of the tangent line at a f of a. Also, we in short call it the slope, m for slope, that's from algebra, of the tangent line. Here's the formula. Limit delta y over delta x as this much gets to zero, meaning f of x minus f of a over x minus a, that's my y2 f of x, that's my y1 f of a, so that's my x1 and that's my x2. As x approaches a, so if we have a here and we have x moves and moves and moves and moves closer to a, the secant becomes tangent. So this is the limit concept. Whenever you have a limit, we are in the derivative mode. Without limit, it's just called secant, and slope of the secant. Here's another form. Limit f of a plus h minus f of a over h as h approaches 0. This is delta x. Between a and here another point is called a plus h. A plus some difference called h. So at this point here, its image will be f of a plus h, and this point its image will be f of a minus the difference between a plus h and a, and that's h. These two formulas are the major part for this lecture and this video. Here is more details. That's called the derivative. It's the slope of the tangent. It's called limit of f of x minus f of a over x minus a as x approaches a. The graph says it a lot. Here's a, here's x. We need x minus a. That's called the difference. That's x minus a. That's delta x, the difference. This difference right here is called usually delta y. It's called here f of x minus f of a. But we have a secant, and we keep moving x towards a, and we have different graphs of secants. They get closer and closer to the green line, and then it becomes tangent. So as a limit, when x approaches a, you don't have a secant anymore. You'll have a tangent. And the slope is not called slope of the secant. It's going to be called the slope of the tangent. And in short, we call it f prime at a. Differently, if you don't want to call it a and x and f of a and f of x, we call it a and some difference, a plus h. See, if you subtract these two, a plus h minus a is just the difference, which is h right here. So the output for a is f of a, the output for a plus h is f of a plus h. This is delta y, and this is delta x right here. In this case, this is delta x, and this is delta y. So for this formula, this is delta y over delta x, and that's right here, f of a plus h minus f of a over h, as h approaches 0, which is this much approaches 0. All right, that's the derivative. So if I minimize the graphs right here for you so I could write some notes, here's some notes. The slope, which is the slope of the secant, is f of x minus f of a over x minus a. There is no limit. That's called secant. If I apply to the same thing the limit as x approaches a, as you could see, I moved from blue to green. This is the blue and this is the green. I move from the slope of the secant to the slope of the tangent, and this is what I have. We call it in short f prime of a. If you use this notations, you will have the following. The slope of the secant, that's the blue one, is the difference in y over the difference in x, and that's it. But if you want the derivative, you need to apply the limit. You see, this has a limit. So whenever you want the limit or apply the limit, you get the f prime, which is called the slope of the tangent. Let's take an example. Find the equation of the tangent line to the graph of f of x equals minus 5x plus 1 at the point 1, negative 4. I'm gonna speed up a little bit. I have all the steps. You could slow down and pause the video whenever you want. I mentioned that before and I'll say it again. Hitting the space bar will stop the video. Hitting the space bar again will move the video back in play mode. So I'm gonna fill this page. To find the equation of the tangent line, usually to find the equation of a line we need mainly a point and a slope. So we have the point, we need the slope at that location. Because it's called tangent, we're speaking limits, we're not speaking just delta y over delta x. So here's the slope of the tangent line, limit f of x minus f of a, but my a is 1. This is my x that we want the tangent to be there at 1 over x minus 1. So what is f of x? It's already here. I just plug it in, minus 5x plus 1. And what is f of 1? F of 1 is minus 5 times 1 plus 4 plus 1, which is actually minus 4. I'm thinking ahead. Minus 5 times 1 is minus 5 plus 1 is negative 4. Since we have a subtraction, I have it. For this I use brackets, for this I use brackets just to distinguish and make it clear. We need to simplify algebra steps. As you could see, I have all the steps. I just wanna try to save you some time and go a little bit fast with the steps. We know how to do the algebra, so let's move on. This minus becomes plus. I don't want to read the whole thing. I'm just reading or highlighting the main pieces. I have 1 plus 4, which is 5. Factor out the negative 5. So I could have x minus 1. And with practice, you're going to see this a lot. What's happening and what you need to know from these examples is the following. Notice earlier right here in the formula, as x approaches 1, I can't plug in 1. 1 will cause the denominator to be 0. Here also will cause the numerator to be 0. So we cannot do that. We need to do the algebra simplify, get to the point that I have no problem anymore. See, this denominator was the main issue. Focus on the denominator till you cancel it, get rid of it, and be able to plug in numbers. Well, in this case, it's a straight line, so it's not doing much for me as calculations. Okay, so one example is not enough. I have more examples. Notice this cancels and I have -5, but what's the limit of -5 as x approaches 1? You know the limits. There is no x involved here, so -5 is not going to change or go anywhere. It's going to be -5. Now, let's see it in a different way. We did this formula. Let's do it in another way. That's the other formula. F of x plus h minus f of x over h, but we are concerned about a equals or x equals 1. So I'm plugging f1 just like this. Instead of f of x, we're using f of x plus h. Let's see how we could do this. Now, f of 1, same idea. You just plug in -5 times 1 plus 1. F of 1 plus h, you take 1 plus h and plug it in right here. So you multiply it by -5, then add 1. Multiply it by -5, the 1 plus h, then add 1. One more thing, steps of algebra, basic steps. I'm just gonna go further. You could slow down and see the whole steps. I'm trying not to skip steps from writing to help anyone see it and believe in those answers. -5 times 1 plus h, distributive property. That's what I did. I simplified this. -4. We did this before. Minus 4 becomes +4. 1 and -5 is -4. +4, -4 cancels. Then h cancels. You can't cancel h yet. You have to be with products. You can't have something plus and cancel it. Limit -5 as h approaches 0. Of course, h goes to 0 or h goes to 7. It doesn't make any difference. -5 is not going to change. Doesn't have a variable. Same answer. Don't you like it when you get the same answer? At least I do. It's nice when you have the steps and you don't have any mistake and you get the right answer. It's a good feeling. Now, the problem says find the equation. We're not done. All what we did here is we found the slope. So the rest is algebra 1. To find the equation of the tangent line, at this point, we're doing the following. We have the slope as -5. And we have y minus y1 equals m times x minus x1 at 1, -4. y1 is -4. That's from here. x1 is 1. That's from here. Slope is -5 down here. Simplify. That's a +4. Do the distributive. Subtract 4 to leave y alone. I get y equals -5x plus 1. Now, just a comment. I don't want to confuse you, but this is a line. The tangent for a line is just a line. It's itself. It's not going to be. If this is a curve, that's going to be different. But it's the same thing. You see that? -5x plus 1. Let's see some other examples. Now, a projectile is fired vertically upward into the air. Its position in feet above the ground after 1 second is given by the function s of t, which is defined to be -16t to the second plus 100t. And we are given a equals 1. Use limits to determine the instantaneous velocity of the projectile at t equals a for the given a, which is 1. So we're doing the slope of the tangent. We're doing the first derivative at 1. That's pretty much it. This is a parabola. because negative, it's upside down, but we want the tangent to be at 1. What's the slope of that tangent at 1? So S prime, that's what we call it, like F prime. That's one formula. We're using one formula. If you have the choice, take whatever you want, but it's good to practice both just in case. Imagine if the question says use the following formula and you're just practicing the first formula or the other one. So practice both. It helps. Limit as t approaches 1, because that's our target. S of 1, plug in 1, minus 16 times 1 to the second, plus 100 times 1. Do the math, I get 84. Plug in t, well, it's the same thing, same look. Simplify. Take the brackets off. There is no numbers to cancel. That's all what I have. Now we need to get rid of this. That was my advice in the previous example. How do you cancel this? Not yet. We need to clean up this, and I call those skills. You need the skills to finish doing the math. That's why we have Algebra 1 and beyond. It's just like you can't do calculus without Algebra 1. You just need the tools and the basics. Now, if you see, we could factor minus 4 out. And once you do that, I get 4t to the second. You could double check. Minus 25t, and you could double check. And plus 21 to get back negative 84. Now we need to factor this part, and we'll move on. We know how to factor it, but what I did also before I attempt to factor, I took the minus 4 out of the limit. The limit of negative 4 doesn't make any difference, so it's not going to be affected. I took it outside. Knowing limits rules, the limit of the product is the product of the limits, and so on. So I'm using the basic limits concepts from your book, any calculus book. So minus 4 is outside. And now we need to factor this, as I'm looking ahead, as you can see. Once you factor it, this is what you get. Well, always, since you know this is going to cancel, when you factor this, just put this in your way. It's going to work out. That's an advice. So you know one of the factors, you just need to find the other factor. So once you cancel it, it becomes clean. Now, instead of plugging in like 0.9999, you could just plug in 1 and you're done. Let's plug in 1 here. 4 times 1 minus 21. The minus 4 outside, we do not forget it. And this is minus 17. Answer is 68 feet per second. Was mentioned in feet and was mentioned in seconds, so the answer is feet per second. Okay, that's one benefit of the derivatives applying the limit, which is called the instantaneous velocity. Another example. This time I'm writing it as A and B to stay focused. We need the slope, and then we need to find the equation. Find the slope of the tangent line of the function f of x equals square root of 3x plus 3. You know, square root is different than our first example, was a straight line. So we'll see how we're going to do the limit for this. At the point 2, 3. So that's my A or my x, 2. Then determine the equation of the tangent line at the point 2, 3. Part A. The slope of the tangent line is the limit as x approaches 2, because that's our 2 right there. F of x minus f of 2 over x minus 2. F of x, we just plug it in. It's given to me. F of 2, 3 times 2 is 6. 6 plus 3 is 9. Square root of 9 is 3. That's right there. Now what do you think? How can I cancel the x minus 2? That's interesting. This is why I call them skills. 5 examples, sometimes it's not enough for some students. You need more and more. I'm giving you the basics, and hopefully my videos are clear to the point to get you into it and start practicing more. So, how could we simplify this to target this later and cancel it out of our way, so we could be able to plug in x plus 2, sorry, 2 for x, so I could get here this out of my way, because if I still have it, 2 minus 2 is 0, which I can't. This is a idea. So we're going to multiply the top side and the bottom side by square root of 3x plus 3 plus 3. This has a minus 3. This is a plus 3. Why do you do this? Let me help you. If you remember, we have something called a minus b times a plus b is the factored form of a square minus b square. A difference between two squares could be factored to a minus b times a plus b. So we have a minus b right there. That's kind of like my a, and that's kind of like my b. A minus b. I put the other part, the other piece, which is a plus b. Now I have this. And I'm using the same colors, if you notice. This is my a minus b, and I brought in a plus b. So if I multiply the numerators of these two fractions, I get a squared minus b squared. But what's a squared? 3x plus 3. That will cancel the square root. And what's b squared? Well, b squared, b is 3. It's going to give you a 9. And this is what I have right here. It's 3x plus 3 without the square root, minus, we still have the minus, difference between two squared, 9. Simplify, you get 3x minus 6. Factor the 3 out, and you get 3 times x minus 2. So, going back to the problem, I have the following. As expected, the x minus 2 shows up to cancel the x minus 2 down. Now, this is not going to make any difference, or it's not going to be a problem plugging x approaching 2. So we have the 3 on top, and we have this part in red down here. X approaches 2, 3 times 2 is 6, 6 plus 3 is 9, and square root of 9 is 3, 3 plus 3 is 6, 3 over 6 is 1/2. Alright, now we need part P, which is determine the equation of the tangent line. Well, we know how to do it. That's the point slope formula. And the point is 2, 3. And the slope, we just found it, which is half. And now we have y minus 3, that's my y1. X minus 2, that's my x1. And the slope is half from part A. Or you could simplify it and write y equals 1/2 x plus 2. Next, let's take more examples. Find the slope of the tangent line of the function f of x equals 2x plus 1 at the point 0, 1. Determine the equation of the tangent line at the point 0, 1. This time I'm using the other form, the second form. So since we have 0 for x, that's going to be 0 plus h, and that's going to be f of 0. Just plug it in right here and do the math. Twice x, that's my input, twice 0 plus h plus 1 minus twice 0 plus 1 over h. Do the math and simplify. This is 2 times 0, 0 plus 1, it's just 1. 2 times h, because 0 is not going to make any difference. Plus 1 and minus 1 will cancel. I have here only 2h, and this cancels. This is what you should expect all the time. Limit of 2 as h approaches 0 is just 2. The equation of the tangent line at the point 0, 1. Y minus y1 equals m times x minus x1. We have the point 0, 1. we have the slope 2 at this point. 2 here, that's my y1, that's my x1. Simplify it, you get y minus 1 equals 2 times x, or y equals 2x plus 1. That should do it. I will put the time stamps or the bookmarks for those examples one by one in the description below. Wait for more videos coming soon this week. Alright, I'm working on it. I'm working on some other videos for online exams, so Proctorio is one of them. Alright, thank you very much, and we'll see you next time. Thank you for watching. Subscribe and leave me a comment below if you have any comments or questions, and I'll see you in the next video. Thank you again.